So the idea of tracing a proof is really just a way of having a reader of a finished proof respond to each of the lines in the proof. And the reason for doing this is that it reminds us that the way you write the sentences in a proof should sound like instructions to be followed. So to give you a couple of examples of this, I'm going to use the solutions from the handout on section 2.1, the worksheet we did on section 2.1. The last two pages just have a whole bunch of finished proofs on them, and I'll use those as examples of tracing a proof. So when we're reading a proof, this is not, if we're writing the proof, this is now the proof is done, and we want to read through it and try to understand what's going on. So one way that we can do that is by responding to each of the sentences in the proof by doing what it says. So for example, so I just number the lines of the proof. So this will be the first line of the proof. This is the second line. And by line here, I really just mean sentence. It depends on when it, who knows if someone starts a new line or not. So that's the second line. This hence part is the third line, and so on. So so I number the lines of my proof, so I know which one I'm talking about. And then over here, for my trace, I would just respond to what it says. The first line of the proof says, let A and B be even integers. And so if I'm reading the proof, I might say, well, I'll let A be 8 and B be, I don't know, 12. So I'm responding to the first sentence by actually doing it. On the problems that you have on the quiz, I'm telling you what choice to make first so that I can then check to see if you understand tracing. But if you're really tracing a proof that you're trying to read for understanding, you would actually just do what it says. So the second line says, we know this means that A is 2K and B is 2L. So that means that supposedly you know that my A is twice something, and you know that my B is twice something. And you know that because supposedly I promised that I was writing down even numbers. And so when we're tracing the proof, we're just really doing that. So 8 is twice 4, so that's the K. Right? The proof says A is 2K. My A was 8, so 8 was 2 times 4, so my K is 4. The B, the 12, is 2 times L, and so the L for my choice is 6. 12 is twice 6. So it allows me, as I read these statements, to then check the work that's in the problem to make sure it makes sense for actual, honest-to-God numbers that I've chosen. So in line 3, for example, line 3 says A plus B on the left side. So this is one way we can kind of check our algebra. For me, A plus B is 8 plus 12. Right? So that's what my left side looks like. Equals, and there's going to be some other algebra, but I can just skip over to the end here and just check, is this really the same as 2 times K plus L, right? K plus L is there. So my K is 4 and my L is 6. So I can check to make sure that that really is true for my numbers. 8 plus 12 is 20. This says twice 10, so that's all good. So that line seems like it's completely fine for that choice of A and B. And then finally I can read the last line. Since 10 is an integer, this shows that 20 is even. Right? I can read that through, again, with numbers instead of letters. So this is based on the idea that sometimes in a proof, you're going to see abstraction, you're going to see algebra, and references to abstract definitions and concepts, and you may get lost in the abstraction. If that happens to you, you can go back and actually follow the instructions as if they're instructions, and you won't be checking algebra when you do that. You'll just be checking arithmetic for one particular example. Now, this doesn't mean that the proof is correct. It just means that the proof, that we didn't find anything wrong with the proof for this choice of A and B. Okay, so the proof has to stand on its own merit. We're not saying that because I found an example where everything works okay, then the proof must be fine. The proof has to be correct with algebra and all the logic that has to be there. But if we find ourselves in a situation of reading through a proof and there's something in it that's too abstract, or there are just too many letters, too many variables, and we're losing track of what it means, we can always do this tracing in order to change the problem into a problem about numbers and arithmetic instead of a problem about variables and algebra.